Well, hello guys, I'm Mr. G with another question. This time we're going to be solving a question on electric circuit, and I will leave the question in the description below. This question says in the circuit below, the connecting wires and the battery have negligible resistance. And then here you have the circuit. The first question says define the term resistance. And we can say that the resistance is, so we can say that the resistance is the opposition to the flow of electrons or to the flow of electric current or electric charge, and you will get the marks there. Question 9.2. Calculate the equivalent resistance of the resistors connected in parallel. Remember, the parallel connection, the resistor or the current will be split, will be divided, and then we'll have a common terminal. In other words, in you to get an idea, this current will flow from positive all the way in this direction, will continue here, but when go to this point, the current will be split in two parts, and this is the beginning of the parallel circuit. Okay, so all the current will come here together again, and then the parallel circuit is done. So the current will flow if the circuit, if the switch is closed, the current will flow all the way back to the battery, and that is the way in which current flows. So the parallel connection, guys, are these two resistors here. So what is the formula? Let's answer this on top right here, 9.2. What is the formula to calculate resistance in parallel? 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. This formula is given to you. Let me show you real fast because it's right here, the formulas, and there is for parallel. This is for parallel. This is the resistance for parallel. Okay, so that one is the one we write it. There is more because in case you have more than two resistors in parallel. So when you substitute, you have that 1 divided by Rp is equal to 1 divided by 24 plus 1 divided by 8. Okay, and then you will get, so you will get that 1 over Rp is equal to 1 over 6. And guys, be careful, be careful. You can see that the resistance in parallel is the denominator. So how do we solve this one? All we have to do is to swap the numbers around. That's all. Okay. However, in your calculator, if you want, you can write that Rp is equal to 1 over 6, everything to the minus 1. Be careful with that one, and then you will get that the resistance is going to be 6. So Rp, I'm going to write it here, Rp is equal to 6 ohm, and that is the final answer. That one is coming from here. This calculation is quite simple. Another 3 marks, 1, 2, and 3 marks for this one. And the next question is to calculate the total resistance of the circuit. So now, what you need to know here? You need to know that the total resistance, and I'm going to write here external, this one is for higher grades. So all the resistance external is going to be equal to the addition of resistors in series plus resistors in parallel. Okay, this one is question 9.2.2. This one is 9.2.1. Okay, so now here we have the series connection is equal to 2, and the parallel we just calculated and is 6, not equal, is a plus here, plus 6. So we have that the total resistance of this circuit is 8 ohm. Quite simple. Let's fix that ohm. There we go. So that is the answer. This is quite easy, those marks. So now they say, when the switch is closed, the voltmeter connected across the 2 ohm resistor measures 3 volts. So that one is, this voltmeter here is going to be equal to 6 volts. So this potential difference here is 6 volts. Alright, it's given to you. Determine the potential difference across the parallel combination. So what we have that the total potential difference is 24. Alright, so we know that the total potential difference, which is the EMF actually, but this is not EMF, is the terminal potential difference. So let's write here, this is question 9.3. Let's write it here, 9.3. Okay, we have that the total potential difference will also be the addition of potential difference in series plus the potential difference in parallel. Alright, so we know here that the potential difference total, which is 24, is equal to 6 volts plus potential difference in parallel. So if we rearrange, we have that the potential difference in parallel is equal to 24 minus 6, which is equal to 18 volts. And that is the answer. That is the potential difference across the parallel circuit. But remember, because they are in parallel, it means that the potential difference in both of the resistors will be 18 ohm, because potential difference in a parallel connection is the same. Okay, so if you do this one, you'll get 1 mark. They gave 1 mark, only 1 mark for that one, guys. I think they were a little bit stingy, but it's fine. There's 1 mark for that one there. And a charge of 18 coulomb flows through the battery in 6 seconds. Calculate the current in the 2 ohm resistor. So you have to calculate the current here. You have to calculate the current that is flowing through that specific resistor, that is question mark. That is what they want you to calculate. They're giving you charge, they're giving you time. All right. So for this question is 9.4. You need to know that current is the rate of flow of charge. So it's charge divided by time. This one is the current. This one is the definition of current. It could be asked is the rate of flow of charge. The formula is also given to you. I just don't know this formula. Just know arrange differently. This one is I equal to Q divided by time. The formula is given to you just in another way, but it's the same formula. Guys, we have the charge and we have the time. So saying that, we can calculate everything. So we are going to write the formula as they giving you the down. Charge is equal to current multiplied by time, and we are going to substitute because we have everything. This one is 18 coulombs, current, you're looking for that, and then the time is 6 seconds. It's quite simple. When you rearrange this one, you have that current is equal to 18 divided by 6, and that is equal to 3 amperes. End of the question. So this one is the final answer, and in this case, you'll have 1 mark for the formula, 1 for the substitution, and 1 for the final answer. It's quite simple. However, in this case, you can also use Ohm's law. Ohm's law is for grade 11, but it's very simple. So we're going to say, or you can say here that current is equal to potential difference divided by resistance. So current will be equal to the potential difference that flows through the 2 ohm resistor is 6 volts. So it's 6 volts divided by the resistance, which is 2. And then when you say divided by 2, you get that current is equal to 3 amperes. That is the other option that you can do it there. And this one is for grade 11. Same story. 1 mark for the formula, 1 for the substitution, and 1 for the answer. Guys, this is the end of the question and the end of this video. I hope it helped. Thank you for watching. Thumb up. I'll see you next time. Mr. G here.